So now looking at question 2. Reaction time can be measured by recording the time from the dropping of a flag, so the dropping of the flag is the stimulus, to when a person raises their arm. So raising their arm. Okay, so no diagrams to help us understand that, but a flag is dropped and somebody else raises their arm. Complete the sentence. So complete the sentence by putting across, these are 1 mark answers. The sense organ that will receive this stimulus is. So how is the person going to sense the dropping of the flag? Well, they're going to see it. So light energy is going to be entering the eye. So that's the correct answer there. Use the words from the box to complete the sentence. So again, we've got one of the completion questions, 2 marks. So this should be straightforward. Impulses are carried along neurons as something impulses. Well, the answer that fits there is electrical impulses. There are gaps between neurons which are called synapses, or the gaps between the neurons. So again, factual recall there. So we now come to a 3-mark question. It's a describe question. Describe the nerve pathway for this reaction from the stimulus to the response. So this reaction, stimulus to response. Now rather than write the answer, I'm going to draw the answer and help explain what actually happens. So obviously we've got somebody seeing the flag being dropped here. So that's the stimulus. We have an electrical message sent to the central nervous system. So this nerve here is the sensory nerve. So that's important. We get that down for 1 mark. So what we have happening here is we're having the stimulus, which is the flag being dropped, being sensed by the eye, and that electrical message being sent to where? So it's going to be sent to the central nervous system. And that central nervous system, as we know, is made up of 2 parts. So what are they? Of course, they're the brain and the spinal cord. Okay, so not the spinal column or the spine, but the spinal cord. So we're going to continue our story. So processing takes place here in the central nervous system, and now there's another nerve involved. This nerve or neuron is a motor neuron. So the motor neuron sends a message to what? Sends a message to the effector, and in this case it's somebody's arm moving, so we know that's a muscle. Okay, and there is your response. So as you can see, we've gone from the stimulus through the pathway, ending in the response, which is a muscle contracting, moving someone's arm. So if you can describe those elements in the right order, you're going to easily pick up 3 marks. So we're now moving on to part B. The mean reaction times of males and females, different ages, are recorded in the table. So a sensible thing to do at this stage is just to try and understand what this table is telling us. So we can see the age going up every 10 years, the reaction times of males and females. We can see how those change every decade. So what's the question asking us first of all? Use the data in the table. So using the data, state the age of males the fastest reaction time for 1 mark. So we just need to look up in the table what males have the fastest reaction time. So the fastest reaction time will obviously be the lowest number, and it's 20 years of age, so just 20 is all we need there. Next question. Compare. We know that's a higher order thinking question, and not surprisingly 3 marks. So what are we comparing? We're comparing the effective age on the average reaction times, mean reaction times of males with females. So not a terribly well worded question, but we're comparing males with females. What are we comparing? The reaction times. So let's have a look. Again, I don't think I'm going to write the answer, but just give you the key points. We'll certainly look at the table and find out what those key points are. So what's the first thing we can say? Well, we can say that from 20 years of age and onwards, the reaction times get slower. And that's true for females as well. You'll notice that the 10-year-old reaction times are a little bit slower than the 20-year-olds. So it's important that we note that reaction times from 20 onwards get slower. So reaction times from 20 years old get slower for both males and females. What's the second thing we can notice here? Well, we'll probably notice that the male's reaction time are always faster than the females. There's another good comparison. Males' reaction times are faster than females. And that's actually true for all ages. So let's put that down. For all ages. We find a third thing? A third point? Well, we've probably already picked up our 3 marks, to be honest. But to find a third thing, we might mention that for both males and females, the reaction time actually gets faster from age 10 to 20. From age 10 to 20, reaction time gets faster for both males and females. So there's always that comparison for both males and females. So there's your answer there.